Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. We will see a video lecture series on shift registers and counters. So in this video, let us see about serial in, serial out shift register. So before going into different types of shift register, we will see what is shift register. A group of flip-flops which is used to store multiple bits of data and the data is moved from one flip-flop to another is known as shift register. The bits stored in registers shifted when the clock pulse is applied within and inside or outside the registers. To form an n-bit shift register, we have to connect n number of flip-flops. So, the number of bits of the binary number is directly proportional to the number of flip-flops. The flip-flops are connected in such a way that the first flip-flop's output becomes the input of the other flip-flop. A shift register can shift the bits either to the left or to the right. A shift register which shifts the bit to the left is known as a shift register, which is a shift left register, and if shifts the bits to the right, it is known as right left shift register. The shift registers are classified into following types: serial in, serial out, serial in, parallel in, serial out, parallel in, parallel out, bidirectional shift register, and universal shift register. So we will see about what is serial in, serial out shift register. In serial in, serial out, the input is also serial and the output is also serial. The data is shifted in or out serially. In SISO, a single bit is shifted at a time in either right or left direction under clock control. Initially, all the flip-flops are set in reset condition. That is, Y3 is equal to Y2 is equal to Y1 is equal to Y0 is equal to 0, which means all the outputs Q3, Q2, Q1, Q0 are 0. If we pass the binary number 1111, the LSB bit of the number is applied first to the D input. The D3 input of the third flip-flop, that is flip-flop 3, is directly connected to the serial data input D3. The output Y3 is passed to the data input D2 of the next flip-flop. This process remains the same for the remaining flip-flops. So the block diagram of a serial in, serial out shift register is shown in the figure. Next, we will see the operation of SISO. So when the clock signal application is disabled, all the outputs will be equal to 0. So the LSB bit of the number is passed to the data input D, that is D3. We will apply the clock and this time the value of D3 is 1. The first flip-flop, that is flip-flop 3, is set and the word is stored in the register at the first falling edge of the clock. Now the stored word will be 1000. The next bit of the binary number, that is 1, is passed to the data input D2. The second flip-flop, flip-flop 2, is set and the word is stored when the next negative edge of the clock hits. The stored word is changed to 1100. The next bit of the binary number, that is 1, is passed to the data input D1 and the clock is applied. The third flip-flop, flip-flop 1, is set and the word is stored when the negative edge of the clock hits again. Now the stored word changes to 1110. Similarly, the last bit of the binary number, that is 1, is passed to the data input D0 and the clock is applied. The last flip-flop is set and the word is stored when the clock's negative edge arrives. So finally, the stored word is 1111 as shown in the diagram here. So this is a truth table of uh, serial in, serial out shift register. So if we are giving the input in series as 1111, and this input is given only to the first flip-flop D3. So whenever a clock pulse is applied, the output of the first flip-flop is shifted to the second flip-flop, and then to the third, and then to the fourth as shown here. And finally, after 4 clock pulses, the entire data 1111 will be received at the receiver. So this is a diagram which is shown in the form of a waveform. So here clock pulses are shown, and the data input initially it will be 0000, and next at the first clock pulse negative edge, you'll be getting the output of the first flip-flop as 1, and all the remaining 3 flip-flop will be 0. And when the second negative edges comes, it will be 1100. When the third negative edge comes, it will be changing to 1110. And when fourth negative edge comes, it will change to 1111. Hope you understood what is serial in, serial out, shift register, and how it works. Let us take up some assessment questions. Based on how binary information is entered or shifted out, shift registers are classified into dash categories. If the choices are 2, 3, 4, and 5. Yes, the answer is 4. Assume that a 4-bit serial in, serial out shift register is initially clear. We wish to store the nibble 1100. What will be the 4-bit pattern after the second clock pulse? That is rightmost bit first. The answer is 0000. Thank you for watching this video.